Both Aristotle and Alexander the Great dreamt of man working underwater. Now that their dream has been made into reality, let's have a deeper look into the world of submarine construction and discover the process of how these marvels of engineering are brought to life. The first step in building a submarine involves designing and planning its specifications. This includes determining the size, shape, propulsion system, armaments, and other features based on the intended use of the submarine. After implementing the design and planning stage, it's time to procure the raw materials. Various materials such as high-strength steel, aluminum, titanium, copper, and advanced composites are used in the construction of submarines. These raw materials are sourced through mining and extraction processes and undergo refining to obtain the desired material forms and are supplied by specialized manufacturers and suppliers. Once the materials reach the site, construction can finally be set into motion, starting with the all-important hull. The hull is the main body of the submarine and is typically made of high-strength steel or advanced composite materials. First, the steel plates are cut into the desired size with acetylene torches. Then, they're bent into shape using industrial-grade rollers. The plates are then placed around a wooden template that outlines the shape of the hull. Once placed, the plates are welded together to form an inner hull. The process is repeated for the outer hull. Space is left between the hulls for the ballast tanks, which are crucial components of a submarine. Submarines are designed to control their buoyancy, allowing them to sink or rise in the water. In the past, this was done with the help of air and water pumps until a scientist named Nathaniel Simons turned the game on its head. Thanks to his contribution, modern submarines use mechanically operated ballast tanks located between the hulls. By flooding these tanks with water, the submarine becomes heavier and sinks. To surface, the submarine pumps out the water from the ballast tanks, reducing its overall weight and increasing buoyancy. Construction materials such as high-strength steel or advanced composites are used to fabricate the tanks, ensuring durability and watertight integrity. The steel plates or composite sections are shaped and formed according to design specifications and then welded or joined together to create the tanks. Protective coatings are applied to the interior and exterior surfaces of the tanks to prevent corrosion and ensure longevity. The tanks are seamlessly integrated into the submarine's hull structure, securely attached and connected to surrounding components. Control systems, including valves, pumps, and piping, are installed to allow the crew to fill or empty the tanks for precise buoyancy control. Once the outer shell is complete, workers begin crafting the interior spaces of the submarines. Submarines have different compartments for crew members, equipment, and various facilities. These compartments include living quarters, control rooms, engine rooms, torpedo rooms, and more. To enable the crew to operate underwater, life support systems are integrated into the inner spaces of the submarine. These systems are vital for providing breathable air, fresh water, and waste management. During the design phase, requirements for crew size and mission duration are considered. Components like air purification units, water desalination systems, and waste treatment systems are procured from manufacturers and integrated into the submarine's compartments. To make the submarine functional, various complex systems need to be integrated into the hull. This includes the propulsion system, engines, propellers, and electric motors, navigation systems, communication systems, weapon systems, sonar, and periscopes. Propulsion systems for submarines are carefully designed and selected based on factors like intended use, range, and speed. When on the surface, diesel engines power the submarine and charge the batteries. When submerged, the submarine switches to electric propulsion using stored electrical energy from the batteries. All these components are manufactured separately and then integrated into the submarine's hull. Mechanical and electrical connections are established to transmit power from the engines to the various components. Afterward, navigation systems, including sonar, gyroscopes, and GPS, are installed in submarines to determine position, track vessels, and avoid obstacles. They are then connected to power and data networks. Calibration ensures accurate readings and functionality for precise navigation and situational awareness. Before a submarine is commissioned, it undergoes rigorous testing and trials to ensure its performance and safety. This includes leak testing, pressure testing, sea trials, and evaluations of various systems. These tests help identify any issues or areas that require improvement. The entire process can cost anywhere from $80,000 to $80 million, depending on the submarine size and functionality. However, if the submarine in question is a nuclear submarine, the price tag can jump up to $3 billion. Let us know in the comments what our next video should be about.